Hi everyone. In this lesson, I will derive the power angle curve for a synchronous generator connected to an infinite bus through a purely reactive line. So in this derivation, we'll derive the first one, that is the P is equal to EV by X of sine delta and Q is equal to EV by X of cos delta minus V square of X. So without I will not skip a single step for this derivation. We'll do step by step. So here I have written that the figure shows a synchronous machine connected to an infinite bus through a transmission line of reactance X. Now let us assume that the line resistance and the capacitance are neglected. So that's why it is the purely reactive line. So here the generator E of angle delta, and the series reactance Jx and the infinite bus is at the angle of V of angle of 0 degree. So the internal EMF of the synchronous machine is E of angle delta. Next one, if needs an infinite bus, and that is the V of angle of 0 degree, already have mentioned in the diagram, through a series reactance here Jx. Assumptions that the line resistance and the shunt capacitances are neglected here, so the path is purely reactive and delta is the load or the torque angle, and the angle of E measured from the bus voltage V. So we will work per phase and will take V as the reference phasor at the 0 degree. Now what we have to do in this equation, we have to apply the KVL equation. So from the above diagram, we can write here that Ij of X minus of B, that is the minus, it will be the minus here, minus of Ij of X minus of V plus E is equal to 0. This is the KVL equation here. Now if you want to solve for the current I, so we can write here that E minus V, E have written here, and minus of V is equal to Ij of X. From this equation only we have written this equation. So similarly we can write here I is equal to E minus V by of Jx. From the above equation only I have written this part. So if you want to express with angle the above equation, so we can write here I is equal to E of angle I, so we can write here that I is equal to E of angle delta minus of V of angle 0 by of Jx. So this gives the, this gives the per phase current through the purely reactive path. So this equation we have written from the above diagram. That already we have drawn here. From the KVL equation. So these things we have to remember. First one, that is the I is equal to EV minus X by Jx, and whenever we want to express in the angles, I is equal to E of angle delta minus of V of angle 0 by J of X. Now what we have to do, the next step will be here that now expanding the current equations. If you want to expand the current equations, so we can write here I is equal to E of angle delta minus V of angle 0 by J of X. Now we have to split into the fractions. So how can we write already this equation? From this equation, E of angle of delta by Jx minus of V of angle 0 by Jx. Now express the denominator J of X as X of angle 0. s of angle 0. So we can write from the above equation only we have written this formula, that is the E of angle 0 minus of x angle of 0 minus v by angle of 0 by x of angle 0 degree angle of 90 degree. So why I have written there, because now we want to express the denominator jx as the angle of 90 degree, then we can write these equations. So these equations we can write from the above equations only. So now remember that j is equal to angle of 90 degree. So jx becomes the x angle of 90. This makes the phasor division easier. That's why I have written in this form. So after that, from the above equation only we can write I is equal to E by x angle of delta. This one delta by this delta by 90 degree. So we can write a delta minus 90 degree. So we have written delta minus 90 degree minus v by x. This is the 0 minus 90 degree I have written here. So the 0 we can remove this one. So directly we can write here I is equal to E by x as it is we have written here. Now minus v by x at the angle of minus 90 degree will be here. So whenever we'll take the conjugate of the current, so we can write here I conjugate of the that is we can write here E by x. So here this is the 90 delta minus 90. If we take the conjugate, 90 minus delta will come here, the minus sign will get changed here, and the minus v by x, that is the minus here, minus of minus will become the plus of plus. So it will become the 90 degree. So whenever complex power equations, complex power at the bus, so we know that the complex S is equal to V into I. S is equal to V into I of conjugate. So already S is equal to V conjugate. So from the above equations, this equation we will put the value of I here, I conjugate here. So V into, as it is we have written, is equal to E by x of angle of 90 minus degree minus of V by x angle of 90 degree. So whenever we'll expand into the rectangular form, so we know that in the rectangular form we know one thing, that we can write here m of angle of theta is equal to m of cos theta plus of j of m of sin theta here. So from this formula only we can write this one. From I will tell you that x is equal to, we have written this one, when we will expand this one, s is equal to p plus jq, from where only we have written here, that is the, and after that we have to multiply v to the bracket. So ve by x angle of 90 minus delta, v into v will do v square of x angle of 90 degree, So this is the second thing. Already this is the, we got this formula from the above equations. After that we have to convert into the rectangular form. So we know that s is equal to p plus jq, s is equal to p plus jq. So we have written here v by x cos of 90 minus delta plus j of sin of 90 minus delta minus v square of x cos of 90 plus j of sin of 90 degree. So already I have told you in the sometimes before only, that we can write here m of angle of theta is equal to m of cos theta plus of j of m of sin theta. So before going to the next step, we should remember some of the formula, that is the cos of 90 degree minus theta is equal to sin theta, sin of 90 minus theta is equal to cos theta, and cos of 90 degree is equal to 0, and sin of 90 is equal to 1. So whenever we keep this formula to the above equation, in this equation means we have to substitute and simplified values, and after that we have to equate the real and imaginary part. We'll see again. So what we have done here, P plus jq is equal to V by x. Cos of 90 minus theta is equal to cos 90 minus theta or 90 minus delta is equal to will be the sine theta plus of j of the sine of 90 minus delta is equal to cos delta. So we have written j of cos delta is equal minus of v square by x. Cos of 90 is equal to 0, j of sine t is equal to 1. So we written j into 1 we can write here. So again if we want to simplify the equations, so then we can write here that p plus jk is equal to ve by x sine of theta, that is from here actually we have written j of cos delta minus of j into 1. Okay na, so we can write here j we took here and v square by x here, so we have written here. Now so from these equation, from this equation what we can do here, that we can equating the real imaginary parts, it will be the p is equal to ev by x of sine delta. How it will be there, that you can see here, this is the only we have the real parts and this is the imaginary parts we have. So what is remaining here, that is we can write here ev by x of sine delta plus q. So that is a p plus the p is equal to the p is the real part and q is the imaginary part here. So p is equal to ev by x of sine of delta and q is equal to ev by x cos of delta, because you read see here ve by. So if we'll multiply to this to the internal part or in the bracket, so we can write ve by x of cos of delta minus v square by x. So this is the two equations we got here. So these are the fundamental power equations of a synchronous generator connected to an infinite bus through a purely reactive line. Now one thing also we can say here, that the maximum steady state active power transfer occurs when delta is equal to 90 degree. So already we know that is the p formula already we have derived here, that is the p is equal to ev by x of sine of delta. So we can write here p maximum, that we are trying to find out for the maximum steady state active power. So p max will be equal to ev by x